last lesson, I left a question with you. I asked you to describe the change of the pH of the solution in case 1. So the answer would be, since the concentration of sulfuric acid increased, hence the concentration of H plus also increased, and that leads to the decrease of the pH value. Hence, the solution would be more acidic over time. So today we're going to move on to the second case. Okay, the electrolysis of very dilute sodium chloride. The key word here is very dilute. Okay. So again, step 1, we're going to list out all the ions that exist in the electrolyte. So in this case, again, the solvent water would dissociate to provide H plus and OH minus for us. And also we have put sodium chloride in the solution. That means it will provide sodium ion and also chloride ion. Then the second step, we're going to consider, do we have halide ions? So in this case, yes, we have chloride ion. However, we only take into consideration when the halide ion are in high concentration. But this case is very dilute, so around 0.005 molar. So the answer for this question gonna be no, since it has only very low concentration. And then the next question, we need to consider the nature of the electrode. According to the diagram, this case, we use carbon electrode, which are inner electrodes. So we could answer no for this one. So the last step, we need to consider what are the ions attracted to different electrodes and which of the ion would be discharged. So as a positive electrode, the anion gonna be attracted to it. So the ions are OH minus and also Cl minus. And as a negative electrode, cations will be attracted to it. So that would be Na plus and also H plus. Okay, so now we need to compare their position in the electrochemical series and decide which one will be discharged first. Let's look at the anion first. If we go back to page 6, we have a section of the electrochemical series here, and we can find that hydroxide ion are on the top, and we also have chloride ion in the middle. As we go up the table, the reducing power increase. That means hydroxide are stronger reducing agent than chloride ion. So hydroxide ions will lose electron more readily than chloride ion. So in this case, we can conclude that hydroxide ion will be discharged. And then let's take a look at the negative electrode. Negative electrode, we have sodium ion and hydrogen ion. So on the left-hand side, we have this section of the electrochemical series here. We can find that we have sodium ions here and hydrogen ions here. So as we go down the table, the oxidizing power increase. Hence, we can say hydrogen ion are stronger oxidizing agent than sodium ion, so it will gain electron more readily. So we can conclude that hydrogen ion will be discharged in this case. So now we've gone through 4 steps, and we can use the information that we have got to fill in the parts on the left-hand side. Okay, so let's deal with the negative electrode first. As a negative electrode, hydrogen ion is preferentially discharged to form hydrogen gas, as hydrogen ion is a stronger oxidizing agent than sodium ion. Okay, and the half equation would be hydrogen ion turned into hydrogen gas. Okay, make sure you balance the equation and write the state symbol accordingly. Okay, so as it gains electrons, so we can also call it the cathode. Okay, so as a positive electron, anions will be attracted here, and OH minus is preferentially discharged to form oxygen gas, as OH minus is a stronger reducing agent than chloride ion. And the half equation will be OH minus turned into oxygen gas. Okay, and the way to balance this equation, please refer to lesson 1 video. Okay, and it will produce water and also release some electrons. Okay, so since it's a release electron, so we can also name it as the anode. Okay, so on the diagram, we can label on the as the positive electron, oxygen gas will be produced. As the negative electron, hydrogen gas will be produced. Okay, and if we combine the two half equation, okay, this one and also this one, we can get the overall equation. So it will be the water molecule turned into hydrogen gas and also oxygen gas. Okay, and by looking at the overall equation, the mole ratio of hydrogen gas and oxygen gas tell us that the hydrogen gas produced here will be twice as much as the oxygen produced. So the volume of oxygen produced is half of the volume of the hydrogen gas that's produced. Okay, so 1:2 ratio. Now the last thing we need to do is to use equations to help us to conclude what are going to be the changes on the electrolyte. By looking at the overall equation here, okay, we know that water has been constantly removed from the solution, so we have less amount of the solvent in this case, but we have not used any sodium ions or chloride ion, so the total amount of the solute in the solution, which is sodium chloride, stay the same. Hence, the concentration of sodium chloride would increase. Okay, would increase. So again, this time I will leave one question for you to answer. What would be the pH change around each electrode? So I expect your answer to have two sections. One, you're going to tell me what's the pH change as a positive electrode, okay, at this part. And the second half, you're going to tell me what's the pH change around the negative electrode, okay, so around this region. Let's move on to case 3, the electrolysis of dilute or concentrated sodium chloride solution. So the keywords here are dilute or concentrated. Okay, so again, let's follow the 4 steps. First, list out all the ions that exist in the electrolyte. So, first of all, the solvent water would give us hydrogen ions and also hydroxide ion. In this case, again, we have sodium chloride as a solute, so it will provide us with sodium ion and also chloride ion. So total, there are 4 types of ions exist in the electrolyte. Then secondly, we need to consider, are there any halide ion in the electrolyte? And the answer is yes, we have chloride ion. And then we need to consider, is it in high concentration? Okay, so in this case, we consider it as a high concentration. Yeah, so we would give an answer of yes for this question. Okay, and the ions exist are halide ion. And then is a move on to the third step. Is a metal electrode used here? Again, if we look at the setup for this case, we use carbon electrode for both electrodes. So that's inner electrode, and we can answer no for this question. And then lastly, we need to consider which one of the ion would be discharged. Okay, so anions will be attracted to the positive electrode, so that would be hydroxide ion and also chloride ion. Okay, and then for the negative electrode, cations will be attracted, so that would be sodium ions and then hydrogen ion. Okay, so for sodium ion and hydrogen ions, we have discussed in case 2. So hydrogen ions would be the one that preferentially discharge. And then let's take a look at the positive electrode. Now we have hydroxide ion, and then we have a very high concentration of chloride ion. And just to give you a picture of this, suppose, for example, we are using 2.5 molar of sodium chloride solution as an electrolyte, then we would describe our chloride ion concentration would be 2.5 molar, and then we would be able to calculate the how much hydroxide ion would be produced by dissociation of water, and the concentration of the hydroxide ion that produced by dissociation of water is just around 10 to the power of -7 molar. So you can see there is a significant difference between the chloride ion concentration and hydroxide ion concentration. That means at the negative electrode, there are so many chloride ions around it. That means chloride ion will have a very high chance of losing electrons here. Okay, it's much more likely to have a reaction when compared to hydroxide ion. Okay, hydroxide ion only exists with a tiny amount compared to chloride ion. So in this case, we would describe that it's the chloride ion which exists at a high concentration that would preferentially discharge. So now, using all the information we get here, let's fill in the left-hand side part. Let's go for the easy one, the negative electrode. Okay, so as a negative electrode, we say hydrogen ion is preferentially discharged to form hydrogen gas, as hydrogen ion is a stronger oxidizing agent than sodium ion. Some of you may challenge that in this case, sodium ion also exists as a very high concentration. So why it's not sodium ion who got the electron and become sodium metal? Okay, remember, sodium metal is really reactive, and we have learned in grade 10 the sodium metal readily react with water, and it will undergo this reaction. Okay, sodium react with water, and it will produce sodium hydroxide and also release hydrogen gas. Okay, so let's balance this equation at the state symbol. Okay, so even though the high concentration of sodium ion is much higher than hydrogen ion, and it may in principle means sodium ion got a higher chance of to undergo a reaction However, as soon as sodium metal is formed, then it will react with water again and go back to sodium ion. So in this case, sodium ion will not be discharged, and instead it's the hydrogen ion that is preferentially discharged. So that's at the negative electron. In the half equation, again, it would be hydrogen ion that goes to hydrogen gas. So it will gain 2 electrons, and then we balance the equation. Okay, so since it gains electron, that's our cathode. Okay, so let's take a look at the positive electron. As we discussed, as a positive electron, since chloride is at a very high concentration, so chloride ion is preferentially discharged to form chlorine gas. Okay, and the reason for that is chloride ion is the concentration of chloride ion is much higher than hydroxide ion. And then we can write the half equation for this. Chloride ion become chlorine gas. And then we balance the equation, balance the charge, and add state symbol for that. Okay, so since it releases electron, we name it as our anode in this case. Okay, so by combining the two half equations, now we can work out the overall equation. So just add these two, and the overall equation would be hydrogen ion plus chloride ion, and then release hydrogen gas and chlorine gas. So if I take a look at the diagram here, we can see on the left hand side, which is our positive electrode, okay, chlorine gas is produced. On the right hand side, which is a negative electrode, we have our hydrogen gas produced. And if we compare the mole ratio in the overall equation, in principle, it should be 1:1 ratio. So we expect the volume of the chlorine gas and hydrogen gas produced roughly 1:1. Okay. Why I said roughly 1:1? Okay, that's because chlorine gas would slightly dissolve in water and form and undergo the disproportionation reaction that we learned in Unit 20. And when we discuss the changes on the electrode, we're going to write that equation now. Okay, so let's use the information that we have written out to conclude what we are going to observe in this case. So overall, what's going to be happen to the electrolyte is that we constantly removing hydroxide ion in the electrolyte. That means it's gonna left us with excess hydroxide ion in the electrolyte. Hence, we could conclude the electrolyte becomes alkaline over time. So let's write this down. So the overall electrolyte becomes alkaline as hydrogen ion is discharged and excess hydroxide ion remains. Okay, so that's the change on the electrolyte. And then let's discuss the change near each electrode separately. So let's take a look at the positive electrode here. At the positive electrode, chloride ion is used and it generates chlorine gas. And chlorine gas, a small amount of chlorine gas would dissolve in water and then form acid. So the pH around the positive electrode would decrease and become more acidic. So pH at the positive electrode decreases and it becomes more acidic as chlorine gas formed dissolves in the electrolyte to form acid. So the equation would be chlorine plus water undergo reaction to form HCl plus HClO. That's at the positive electrode. And on the negative electrode, as a negative electrode, we use hydrogen ion only, so it will left us with excess hydroxide ion. Hence, the pH as a negative electrode would increase, and we say it becomes more alkaline. So, pH at the negative electrodes increases, becomes alkaline as hydrogen ion is used and excess hydroxide ion remain. Okay, so on the diagram, actually you will see the chlorine gas produced is slightly less than the hydrogen gas produced.